Hi, I'm Werner. I'm a developer at Coitec. In order to dimension a system from a power perspective, we need to consider both the power source and the load. Today we'll be looking at a specific load, a Bluetooth receiver from Nordic Semiconductor. When measuring power consumption of devices designed to operate from relatively small batteries, it's important to test both at high and low battery voltages. As the battery is discharged or is exposed to low temperatures, the cell voltage continues to drop. If we start a recording with this device powered by 3 volts, and we need to sample enough to actually get a reasonable average because it spends a lot of time in idle mode. We'll fast forward to the end of the recording, roughly a minute in. So we have roughly a minute of current measurements at 3 volts. I'm gonna stop that. Gonna change the voltage to 2 volts and start a new parallel recording. We can already now see that the current spikes are actually higher when we lower the voltage. This is because the device here is based on an nRF51 series chip from Nordic Semiconductor, which uses a DC-DC converter to step down the battery voltage to the internal core voltages used. Again, we fast forward a bit to the end of the recording here. We're stopping that. And we can now measure, excluding the startup behavior. And we get an average current consumption of 50.8 microamps when powered at 3 volts and 62.5 microamps when powered at 2 volts. The interesting part here is that the device actually consumes less energy on 2 volts than on 3 volts. It means that the amount of energy used is fairly similar, but the battery will discharge at a faster rate the lower the battery voltage gets. Thanks for watching, subscribe to our channel and see you soon.